there is a curve defined like this, and then the input is limited to larger or larger than -2, is because if x is smaller than -2, then what inside the square would become negative and will create imaginary parts. So anyway, they give you this curve and they ask you to differentiate it. That means find the slope function. We write it into a format that which is more favorable for you to differentiate. Therefore, we are going to differentiate by using the product rule. dy dx is equal to differentiate the first one and then keep the second one. We get one time and then we keep the second factor. And then we keep the first factor, we differentiate the second one. That's why we get 1/2, 3x plus 6 power of -1/2. And don't forget by chain rule, you need to differentiate what inside. So it's give you 3. And the separate term -8x is easy to differentiate, just -8. Finally, there is a common factor, 3x plus 6 power of -1/2. We always extract the common factor, we choose the lowest power. So, if we extract the common factor, we will extract 3x plus 6 power of -1/2. The first term, 3x plus 6 power of 1 will be left. And then the second term, we have 3/2. We have x minus 2. And then 3x plus 6 is extracted. Finally, we extract 1/2 also. So, these two terms, we have to times 2. It gives us 6x and 12, and then plus 3x minus 6. We get 9x plus 6 over 2 times of 3x plus 6 power of 1/2. That means 9x plus 6 over 2 square root 3x plus 6 and then minus 8. That's the slope function. In part B, someone claimed that two of the tangents to C are horizontal line, which means that they imply is there any 2 points will make the slope become 0. So we are going to solve this situation and then to find do we have 2 roots or more to fulfill this requirement. If we find 2 roots or more can fulfill this requirement, then we agree the claim. But if we just find 0 roots or 1 root, then we say that we have to disagree the claim. So consider when dy dx is equal to 0. And then we don't want the square root, so next step we are going to take square for both sides. But whenever you take square, you have to bear in mind that you may create a fake answer which provides the same magnitude but not the same sign. It's because the action of taking square totally negate the effect of the sign. That's why we need to check our answer, verify our answer after we solve all the things. If you ever take square on both sides. So we have 81x squared and then plus. We have a quadratic equation, then we can solve it after that. X is equal to 10 or x is equal to -50 over 27. First, you have to check, is this fulfill our domain here? Is that fulfill our requirement here? This is just -1.8 something, so it's fulfill this requirement. We will not reject this result because of the domain. But just like what I mentioned before, the action that we take square may create a fake answer. So that's why we have to test both, not only one, we have to test both to ensure that it's valid. In order to test it, we just need to substitute inside and check whether the slope really equal to 0 after that. So when x is equal to 10, then dy dx is equal to 9 times 10 plus 6 divided by 2 square root 3 times 10 plus 6, and then minus 8. We get 0. So we prove that when x is equal to 10, then the slope of that curve is equal to 0, which means that the tangent at that point is a horizontal line. Now we have to consider another point. When x is equal to negative 50 divided by 27, dy dx is equal to 9 times. We get negative 16, which is not equal to 0. So this is not our target, and you may find that this part gives you negative 8. However, our requirement is this part need to be positive 8. That's why I say that whenever you take square on both sides, you may create a fake answer because you just consider its magnitude, but you do not consider its sign. Therefore, final conclusion, only one tangent is horizontal. Therefore, do not agree.